Welcome to ENTECH STEM Magazine's live session. Today, ENTECH Magazine's Deshmukh and founder editor Dr. Charudatta Pathak are discussing a mind-bending scientific breakthrough. During this session, we are highlighting an incredible news story reported by Juveriya Khan, a science communicator at ENTECH Magazine. She recently covered a groundbreaking study published in the journal Nature Biotechnology. The main researchers behind this invention include Zijing Yu, Bei Zheng, and Yongdeng Zhang. These scientists represent institutions like Westlake University and Fudan University, while the ENTECH report also highlights research from Zhejiang University in China. These researchers achieved near perfect 3D nanoscale resolution inside living cells by putting a simple silver mirror inside a microscope. We are breaking down the science of super resolution microscopy so anyone can understand it. We will also explore the awesome STEM career opportunities this technology creates for teens, from coding to biomedical engineering.
Okay, so here we go. And Dr. Pathak, what are we discussing today? Today we are discussing seeing something which is invisible. That is, okay, you have become a magician or something like that. But let me simplify it for our viewers. So magician is here, and what we are going to do is that whatever we see through the microscope, I'm sure all of you would have seen the microscope in your lab, you would have used it, right? You can keep on adjusting it horizontally so that images are clear, but have you been able to go depth and still the images are clear to you? And that is exactly what is the breakthrough. Though it is simplified version, but let's get into the technology. So Dr. Pathak, what is this technology?
Yeah, I will slightly say that it's a science magic.
Okay.
Yeah, it's like a challenge we face while seeing the molecules or DNA or other living organs at microscopic detail. So that is 200 nanometer, what we say. It's a microscope.
200 nanometers. Okay.
Yeah. And below that, our conventional microscopes, they get blurry. Okay. So it's very difficult to focus. And because this,
so what does this I'm sorry to interrupt you, doctor. What does this left image signify?
Yeah, it's a living cell, we can say.
It's a living cell, and that is
living cell,
blurry, right? Which is
that is blurry. Yeah. It's of course illustration for the explanation purpose. Yeah, it is blurry because you can't go beyond 200 or lesser than 200 nanometers. Okay. So it's a microscopy, and what you are trying to do is nanoscopy.
Okay.
Using microscope.
Okay. All right.
Now the sharpness, you lose the sharpness, then you require a very costly or very niche technology of laser interference, and that too you don't get some live footage. But here the scientists, they are able to see at 2 nanometer, 2.5 nanometer at exceptional detail, just a 3D level.
Yeah, I think the example which you gave it on the screen, if you can go to the previous one, doctor, is to say that if you got a tennis ball and using this technology, you can see the molecules in that tennis ball. It's that kind of a nano, right? Okay,
it's that kind of a zoom level, what we can say. So everyone is like aware of zoom. So we are zooming into that detail, molecular detail. And it's like, we can say, the discovery of maybe year or century. So it will be game changing. It is game changing rather. You can see the result in the near future.
Sure, we can. So how does it work?
The principle, I think researchers have explained in a very simple way. So they got some silver mirror, tiny, and they bounce the light to get that 4pi interference pattern, and the result is that you get 3D precision. Okay.
Because of that.
And even ahead of the conventional, using this very cheap silver mirror, what they call. Okay.
So you take a sample, put a silver mirror on top of it, right? Use whatever else are measuring methods, and that's how you get the result. Okay, understood?
Yeah, that's how we get that they create the pattern.
Okay.
Yeah.
So what is this?
This is like 10 minutes tracking they have claimed, scientists have claimed, fast moving membrane dynamics captured live. So this is something magic, science magic. Okay. So you are
explain me in simple terms. Explain me in simple terms.
See, this older 4PI system to get that laser interference, okay, they could not gather or capture this live cell movement. Okay. Inside it. Yeah. Now with this technology, they have claimed that they have captured a 10-minute footage. How this in 3D. Okay.
In 3D.
So you have got in 3D. So you have got a limitation for even 4PI niche system, which is like today. So I think it may become obsolete and this will prevail. It's not only cheaper, but it's more advanced.
Yeah. Let me have the analogy, right? Like you are showing the picture of a brain scan, right? I can only see the slices in 2 dimension here. So what I can probably imagine that you can see how these cells are functioning in real time over a period of time. Correct? Oh God. Okay. So you are basically putting a CCTV inside the brain. Something like that. And watching it live.
Something like that. It's a brain tissue.
Something like that. Nobody is putting CCTV in the brain, but then for analogy purpose, that's what I wanted to say.
Yeah. So they are getting very sharp pictures here. So this is like, again, I'm saying this is illustration of what they are claiming.
Right.
And this is how the final image is built using a small trick, or that they call a silver mirror.
Okay. Oh, okay. So if somebody is interested into this, what do we do? Right? What are the career paths?
So it is for everyone. So, and not only biologists, it's a spin-off is very high. So it can be used for even electronics can be used, and so physics, chemistry, biology. It's not limited to biology. So this technique they have used for cell, but definitely it can be used for electronics, and you can see a lot of movement, and seeing is believing. So once these curious minds, teens, they see the live cell under the microscope, and I hope the schools, even junior colleges, and even a mid-level institutes, they can afford it if it is made. It's like a democratization. It's a democratization
How
of.
is this fine, doctor? I still have one question. I'm sure we'll be handling that kind of a question. Is what do I do with this? What is the real world impact? Fine, I went ahead, I studied, everything is fine, right? So what do I do with it?
Yeah, first allow me to explain what is this MT4PI SMLM. Okay, what they call. It's a mirror enhanced 4PI. 4PI, it refers to laser interferometry, which is currently used for super resolution microscopy. Okay, but this is what they have prefixed it with ME, mirror enhanced. Okay. And single molecule localization microscopy. So they are they have approached to single molecule.
Okay. Let's move on.
So these are like researchers in China. Yeah. So we will like one lens, one mirror, and world-class precision, what we can say. And you are capturing light, reflect to form wave, and achieve this sharpness to get the 3D picture. Okay. And what is the precision? You can see here, 2 to 3 nanometer.
Yep.
So, and what is the width of human DNA? So around 2.5 nanometer. So you are getting 2 nanometer resolution. So definitely
So
you can see again. Then 15 nanometer is like brain synapse resolution. So this is huge achievement. Okay. For
let's move
research
on.
purpose. Yeah.
Yeah.
Yeah. So you can upgrade existing lab. That is a good thing. Okay. You don't need to purchase new equipment. So with this research, so we are calling it as democratizing the science. Okay. Yeah. What you are talking now, we will discuss it. Yeah. It's of course, applications, as I said, will be many. Okay. Maybe hundreds or thousands. Okay. We can predict it. Okay. Faster drug discovery. Okay. So that is a major application in biotechnology and pharmacy. Brain health monitoring, new research, new findings will come out about our brain, fighting viruses. So, and affordable healthcare, that is a major benefit. As I said, it's a democratization of science. So we are achieving this because we know all this niche area, it cost millions of rupees or dollars. Okay. But now it will be affordable. Because you have like lot of instruments, or you converting all instruments into this.
Just hang on. This is a very interesting topic, right? I mean,
Yeah.
students who are kind of studying today, let's say in 12th standard, or they are graduating, by the time they come into the workforce is another 4 to 6 years, right? If you do the post graduation or so. So one should see how their career is going to look like, let's say in 3 to 5 years from today. So that's why we brought in this particular kind of landscape in by 2030. So how does it look like?
So a lot of researchers will be required, definitely. Lab technicians, lab assistants, even manufacturing industry, silver mirror. So we can expect a lot of demand for silver mirrors.
Okay. And silver is getting costlier day by day. Okay.
Yeah, that's why silver is getting costlier.
Okay.
So they reported this on 31st March, day before yesterday, we can say couple of days back. Okay, this is so recent research, but might be they were knowing that this is like a groundbreaking game changer research, what everyone said. It's mind blowing.
So the scope is in biotech and pharma, medical diagnostics,
semiconductor, neuroscience,
and
huge demand of the researchers, I can say, huge demand. Analysts, researchers, lab technicians, health industry in overall, again, because it's like a democratized.
So we saw these kind of industries, but what kind of roles are there? What do I do there?
A super resolution imaging specialist, as I say, we require human, so who will like capture this, and maybe analyst. Here, I think AI will also come into picture.
Absolutely,
assist, but it will. The good thing, what I can predict is that it may not replace human AI here. Okay, because AI will help the specialist, because we need someone who will analyze the image, who can analyze the image, or who can interpret the image. Okay, and who can take the information which is necessary, because once you go at nanoscale, so take it from me, huge amount of information will be there. Okay, and even if you use AI, you get a condensed information. Out of that condensed information, which information is useful? So definitely you need human being researchers.
I think AI will become a foundation for all sorts of careers going forward. So that point is well taken. So we talked about these kind of roles,
nanoscale,
kind of
metrology engineer, molecular diagnostic consultant, optical system architect.
What I would suggest, doctor, is you can put a link to this particular presentation into our YouTube description so that people can see it.
Sure.
So just winding it up for you, doctor. The key takeaway: there is a breakthrough. We were able to see earlier at a very less resolution. Now we are looking at 2 to 3 nanometer kind of a resolution over here,
Mm-hmm.
right?
Mm-hmm.
It has become accessible to everyone. That's point number 2, right?
Yes.
Because you can easily upgrade, right? And in future,
Mm-hmm.
it can have a lot of benefits to the society. At the same time, it is opening up the careers for future, right? For cures,
Mm-hmm.
drug discoveries, and so on and so forth. So all of you
Yes.
guys who are interested into these kind of careers, do visit our website, have a good look at the presentation, and like and subscribe to our YouTube channel. You would be able to see your career at nanometer depth. So thank you so much,
Yes.
Dr. Pathak.
Thank you, sir.
And then viewers, see you again.
See you again. Please like and subscribe ENTECH Magazine channel. Thank you. Thank you all.